So today's lecture is, this is lecture 11, and today we're going to be talking about Mars, the search for water on Mars, and the idea that there may have been life on Mars, or there possibly is life on Mars right now. So let's just sort of step back and take a look and remind ourselves where Mars is. Mars is the fourth planet from the Sun. It's sort of a smallish planet. So here is Mars, up here right next to the Moon and the Earth, and you see that it's a smallish planet, and this has been important for its evolution. So it's about half the size of Earth and twice the size of the Moon. So it's somewhere right in between the Earth and the Moon. Does anyone remember one thing about the size of Mars that's really affected its evolution and potentially could be very important for life on the planet? There's something about its size, that the fact that it's small, that we think has played a really important role in its habitability. Does anyone know, anyone remember what that is?
It's able to release all the oxygen off its atmosphere?
Yes. I mean, it has to do with oxygen on its atmosphere. It has to do with its atmosphere. I'll give you that. It's not that it can't hold on to oxygen on its atmosphere necessarily because its gravity is weak. It's a little bit, it's a little bit more involved than that. The fact that Mars is small means that it cools off faster than larger planets. So you remember this thing about how large objects radiate their energy effectively more slowly compared to their volume compared to small objects. And again, this is why you tend to find in the Arctic region, you tend to find kind of large animals, because the bigger the animal is, the smaller its surface area is relative to the total mass of stuff it has to cool off. Okay, so generally things radiate energy out of their surfaces, but the total amount of heat that they have is associated with their volume. So as things get larger and larger, the amount of surface area they have compared to their volume is smaller. Okay, so you have more mass. So if you have a very small sphere, a larger fraction of that sphere is covered up by its surface area, you can think of, compared to a larger sphere. And so when heat is leaking out of a planet, it's leaking out of its surface. And so smaller planets have a larger surface relative to their volume than larger planets. So Mars, the inner part of Mars, so the core of Mars, we think has cooled off radiatively faster than the inner part of the Earth. And that's why the Earth has a molten core today. That's one reason why the Earth still has a molten core today and therefore has a magnetic field, whereas Mars, we think, doesn't have much of a molten core, doesn't have a very strong magnetic field. Now, so we've done many steps along the line. Why does having a magnetic field affect a planet's habitability? Who knows this? Sorry, what?
The atmosphere gets blown away.
Very good. So having a magnetic field protects the atmosphere from the solar wind. So you have a solar wind from the sun. It's coming along. Okay, charged particles from the sun. If you've got a planet with a strong magnetic field, those charged particles can be deflected by the magnetic field. Sometimes they train in along the poles, but mostly they're just deflected off. But if you don't have a strong magnetic field, then those charged particles from the sun, the solar wind, can effectively just blow the atmosphere off. And so that's another reason why we think Mars has less of an atmosphere today than the Earth. It's because the Mars is small, it's lost its molten core, it's lost its magnetic field, and has had its atmosphere blown away. So while you might look at these two planets and think, well, they're not that much different, it turns out that being as big as the Earth, we think, has been pretty important for the history of the Earth compared to being something that's just half the size in radius. Of course, that's 2 cubed in volume, so it's a lot smaller in volume. Okay. So anyway, that's Mars. It's a smallish planet. Oops. But otherwise, it turns out, Mars is actually pretty similar to Earth. So besides this thing that it's a little bit smaller, it's got a lot of things going on that are very similar to the Earth. So for example, it spins on its axis. And it spins on its axis once every about 25 hours, or 24 hours and 40 minutes, to be precise. So a Martian day is almost exactly the same length as an Earth day. It's just about 40 minutes longer. Another thing that's interesting about Mars is it's also spinning on an axis, and its axis of spin is about 25 degrees compared to the Earth, which is 23.5. So even its spin axis is not that much different than the Earth. And because it has a spin axis, it goes through seasons, just like the Earth. So different hemispheres on Mars are experiencing summer and winter at different times, just like the Earth. Now, something that is a little bit different is Mars is farther away from the Sun than the Earth, and that means it takes it longer to go around the Sun. So its orbital period is something like 1.9 years. So almost two, when the Earth goes around twice, is almost the same as when the Mars goes around once. So it has a longer year. So while Mars goes through seasons, its seasons are longer than ours, about twice as long, roughly, on average. Okay? So each day is about the same length, but the year is about something like twice as long, a little less than twice as long. All right. Questions about that? Now, now, of course, we mentioned this before, but Mars has a very thin and dry atmosphere. So that's another thing that sort of sets it apart from us. There's only traces of water vapor in Mars's atmosphere, and its average air pressure is only 0.7, 0.6% that of Earth. So it has this very low air pressure. And again, we think that's related to the fact that it doesn't have a magnetic field, and possibly because it's got a little less gravity. It's also extremely windy. It has a weak atmosphere, but it does have some atmosphere, and it does have a windy surface. What's shown here is a movie of a little dust devil swirling along the surface of Mars. Just like the kind of dust devils you'll see in the desert, say in the southwest US, you will see those kind of dirt devils on Mars as well. This one was actually taken from one of the robotic landers called the Spirit rover in 2005. It was a little movie of a dust devil sort of going across its path. An interesting story about these Martian rovers when they were launched. So this was sort of an older generation of Martian rovers that were roaming around on Mars, about 10 years ago. They had originally designed these things to not last particularly long. They thought that they were going to last maybe 6 months, maybe a year. And that's because they're solar powered. They have these solar panels on the top. And the reason why they thought eventually these solar panels would stop working is that there's a lot of dust on the surface of Mars, and the dust would sort of cover up the solar panels, and then they couldn't absorb sunlight anymore, and they couldn't have power anymore. But what they found is that if they looked at the power levels from these solar panels, they would see them falling off like they were expecting, and then every now and then they'd spike back up to where they started, and then they start declining again, and they didn't really know what was going on. And what they eventually realized is that these little dust devils would occasionally just go right over the top of the solar panels of the rovers and clean them off. And they have movies of the rovers taking movies of each other with a little, dust devil going across the top, and it would just clean the thing off like a little vacuum cleaner, and then they would keep going again. So these gusty winds and stuff like that are sort of characteristic of what Mars is really like. And you start to get the sense that, comparing Mars to a desert is a pretty good comparison. I mean, it's windy, it has extreme changes in temperature, and it's extremely, extremely dry. There's almost no water vapor at all on Mars. Now, the average temperature on the surface of Mars is something like minus 60 degrees Fahrenheit, but that can vary a lot throughout the day. Mars has polar ice caps. Okay, so because it's got this inclined axis of rotation, just like on the Earth, where the poles are very cold, the poles of Mars are very cold, and they actually have ice caps that we think contain frozen water ice and frozen carbon dioxide ice, that's dry ice. So it's sort of a mixture of water ice and dry ice on these Martian poles. So you can see these in images. Here's a picture of the North Pole and a picture of the South Pole of Mars, and they have ice caps just like the Earth, and it has ice caps just like the Earth. So the surface of Mars really does look like a desert. It looks kind of like a red desert. And the reason why it's red, it has this kind of rusty brown color. You know, people call Mars the red planet. The reason why it is this kind of reddish color is it contains a lot of iron oxide. So there's a lot of iron bonded with oxygen actually on the surface of Mars, and that's what gives it this kind of rust color. It's sort of rusty colored surface on Mars. Now, one of the reasons why Mars has been sort of fascinating to people, at least, you know, in the last 100 years or so, is that Mars has for a long time been sort of a popular candidate for life. And in fact, you know, even intelligent life on Mars has been a common thing. I mean, the War of the Worlds, which we mentioned briefly, you know, is this famous book from 1898, posited this idea that Martians were coming to the Earth to sort of wage war on us. But there are a large number of sort of science fiction novels, at least, you know, sort of in the past, where people sort of hypothesized this idea that there was life on Mars, and in fact intelligent life on Mars, and this just seemed kind of a normal thing to think about. This was sort of an idea that has become very common. What's interesting is a lot of these ideas actually came out of scientific pursuits. So there were some scientists who were actually thinking that Mars itself might be a habitable planet and might in fact have intelligent life. This is of course a long time ago, but really these ideas were originally coming out of the science, from scientists, and then they were sort of latched onto by science fiction writers that kind of ran with it. And in fact, you know, the earliest studies of Mars really made it look like it was, you know, potentially habitable because it was so similar to the Earth, right? So, you know, by the end of the 18th century, people knew that Mars had ice caps. So even with the quality of telescopes they had then, you could study Mars and you could see that it really did have ice caps. So wow, you see that and you think, boy, this is a lot like the Earth. They knew that Mars had a tilted rotation axis, and they knew that it went through seasons. Again, just like the Earth, and wow, the parallels are really similar there, right? They knew that Mars had a roughly 24 hour and 40-minute day, and they knew then, again, this is looking a lot like the Earth, and so why not? It's got so many things that seem similar to the Earth, why not? People could see dark features on the surface of Mars. So this is an image of Mars, a little movie of Mars you could take through a small telescope, and you might think, okay, this is maybe comparable to the kind of telescopes that people were using at this time. And if you stare at that image, you see that there are some dark spots and some lighter spots as this planet is spinning around, right? You see that, and of course you would love to think about the idea of there being life on Mars, and people began to wonder whether or not you would see these dark features were vegetation. And you would actually see seasonal changes in the nature of some of these spots. And people began to think, well, maybe they're growing in the spring and summer, and they're rescinding in the autumn and the winter, just like they are on Earth. And wow, boy, this is some really interesting possibility. In fact, William Herschel, who was probably, you know, certainly one of the most respected astronomers of his day, in 1784, suggested that Mars probably did have inhabitants, and that their situation was perhaps very similar to our own. And people began trying to even think about how to send signals to people who were living on Mars at that time to see if they could do some kind of communication. Giovanni Schiaparelli, around the year the late 1800s, was the director of the Milan Observatory. And one of the things he was very interested in was mapping out the surface of Mars. And he made these maps of the surface of Mars. And here's one of his maps from 1877. And he noticed that there were features on the surface of Mars that looked like sort of ruts or line-like features on the geography of Mars. And he called them canali. Okay? So these canali were what, you know, if you were an English reader and you read that, you know, you might read this as canal. What he was thinking perhaps more likely was channels, or maybe sort of rifts in the land. But these canali that he talked about, he actually thought of them as natural features, but it turned out that these canali on Mars, these canals on Mars, began to sort of pick up, and people began to think, wow, maybe there's actually a canal-like network on Mars, much like you see canals on the Earth. The person who really ran with this idea was someone named Percival Lowell. And so Lowell was living a little time after that. He lived into the night till around 1916. And he took these canals very seriously, and he started really using his telescope to study these canals, and began to try to make maps of the surface of Mars. Now, in fact, he founded an observatory near Flagstaff, Arizona, that he built with his own private funds. It turns out that he was from a fairly wealthy family, and he was able to channel these funds into building an observatory out near Flagstaff. And that observatory, by the way, still exists today. Lowell Observatory ended up doing a lot of really important science. But the funny story behind it is the reason why it was originally founded is this guy Lowell really thought that there was basically a huge civilization on the surface of Mars building canals there, and he wanted to map those canals out. Okay, he spent 20 years basically observing Mars and drawing pictures of what he saw on Mars. Now, in fact, he mapped out an extensive canal system, and here's one of his maps that he drew out on the surface of Mars. And he had this idea that what the Martian civilization was doing is he had this idea that Mars was a planet that was drying out, but it had all this water locked in its ice caps, and it was building this massive canal system to bring water from the ice caps down to the civilizations who were living sort of in the equatorial regions. And he wrote all of these popular books where he sort of proclaimed the truth that there were these canals on Mars, and the idea that there was this intelligent life and this global civilization on the surface of Mars that were doing these things. And he could see these canals, and therefore it was sort of proof that this kind of like sort of non-natural thing was going on. At that time, most professional astronomers, so people who were not Lowell, didn't actually believe him because people had a lot of trouble reproducing what he saw. So he would make these maps, and then other astronomers would go with a different telescope and try to see the same things, and they could never see them. Lowell always said, that's because your telescope's not as good as mine. I have the best telescope in the world. I have a great site here in Arizona, and that's why you can't see them. If you had my telescope, you could totally see these things. And so it was this sort of dialogue that went on. So here are some examples of the books that he wrote and that sold very well. Here's an example of a newspaper article that was going on at the time that people, and the thing about it is people wanted to believe this, right? This is kind of cool. So people said, a lot of people wanted to believe this was true, and a lot of people sort of thought that maybe this is what was going on. And this idea lasted for a very long time, that there were these canals on Mars. Interestingly, this was not such a crazy idea from a scientific perspective, because early estimates of Mars's atmosphere suggested that there was perhaps enough atmosphere on Mars to allow it to have liquid water. If you remember, I talked a bit about this before, but whether or not you can have liquid water depends not just on the temperature. Okay, we're used to thinking of, when it gets cold, ice, water freezes. When it gets hot, ice melts, and when it gets really hot, the water turns into steam. But the fact that it only depends on temperature is true only if you have a fixed pressure. Okay, if your air pressure changes, then whether you're a solid or liquid or gas changes as well. Okay, and so what you get are these so-called phase diagrams, where what you've plotted here is the pressure versus the temperature. Okay, and so at 1 atmospheric pressure, that's like what we feel here in this room, that would be along this line. And so when it's cold, you have solid ice. When it gets hotter, you have liquid water, and it gets really hot, you have steam. And so there's this fairly wide range of temperatures where you can have liquid water, okay? And that's basically most of the temperature conditions on Earth, right? Now, people didn't know exactly what the air pressure on Mars was, but early estimates for what Mars was like was somewhere, they knew it was lower than the Earth, but they thought it might have been somewhere around maybe a 10th atmospheric pressure, which would then allow for the existence of liquid water with certain temperature ranges. So people thought the idea that you might have flowing liquid water flowing down these canals on the surface of Mars is something that could happen. Now let me just remind you that if you have temperatures, let's go back, if the air pressure is low enough, however, then you get below the thing called the triple point of water. And in that situation, if you can either have solid ice or vapor water, but you cannot have liquid water. Okay, so if the pressure is very, very low, if you have solid ice, it will immediately sublimate to gas, and you'll never have that liquid phase. That's the situation with dry ice. Okay, dry ice is frozen carbon dioxide, and at 1 atmospheric pressure, this is temperature, this is pressure. At 1 atmospheric pressure, you're either solid dry ice or vapor carbon dioxide. You are never liquid carbon dioxide at 1 atmospheric pressure, okay? And that's why you can bring dry ice in and sit it down, and it looks like it's just smoking. You never get a puddle of carbon dioxide on the floor. It just immediately smokes into vapor, okay? So if you were to lower the atmospheric pressure enough, water would behave exactly the same way. You would either have sort of water or liquid ice or vapor, and you would never have a puddle of water. It would not be a stable situation. The first spacecraft to fly by Mars basically proved beyond a shadow of a doubt that there were no canals on Mars, okay, and there were no lush rainforests on Mars. The first things to fly by them were Mariner 4 in 1965 and then Mariner 9 in the early 1970s. They were taking pictures of the surface of Mars and revealing that while it was sort of cratered, it had interesting geological features on it, but there were no rainforests and there were no canals running across the surface of Mars. Also, the atmosphere proved to be a lot less dense than people originally thought, and in fact, we now think that the atmospheric pressure on Mars is below the triple point of water, and so we don't think there's a lot of flowing liquid water on the surface of Mars right now. So liquid water is unstable on Mars. If you went to Mars with a jug of water and opened the jug of water up, it would immediately either freeze or turn to vapor. It would not be stable in a liquid state. So that's kind of bad news, at least for life like our own on the surface of Mars. What were these canals? People don't know, okay? People have thought a lot about what it was that Lowell was seeing on the surface of Mars when he was drawing these maps, because he was very convinced that the maps were there, that these canals were there. One thing that he did talk about was how the canals would be there and then they would go away. So he had this idea that maybe they would rescind them in different times of year and rebuild them. So it wasn't quite clear to him that they were perfectly stable. So it could be that they were basically optical illusions. Another possibility that people have thought about is he may have been actually mapping out the vein structure on the back of his eye. Because if you stare into a bright light, okay, and if you've ever closed your eyes, you know there are sort of, you can pick up the vein structure of your eye if you're really focused on it a lot. And it could be that he was doing that. So he could have been spending like 20 years of his life just mapping out the internal vein structure of his eye. So that's kind of too bad. But the bottom line is, it's easy to pick out. I mean, the funny thing about it is, in the long run, he actually contributed a lot to science because he built this telescope, which ended up being used for lots of really important stuff. It's just that he didn't use it for very important stuff. Yeah. But the thing to keep in mind is that humans are really good at picking out patterns right when they're not there. And that kind of makes sense, right? I mean, we can all see the tiger there, right? We all see that tiger. Now, it could be that there's no tiger there and the grass is just situated in a funny way. But it's better to think you see a tiger and it's not being a tiger than to not see the tiger and then have the tiger eat you, right? So it's a little better to sort of have evolved the ability to see things that aren't there than the other way around, right? And so it could be that, it's sort of that general characteristic that's the case. Another thing that, that reminds us of is that the human brain is particularly good at seeing faces, right? We see faces in everything. The fronts of cars look like faces. You see faces everywhere. The fronts of houses sort of look like faces to us, right? The human brain is really good at recognizing faces. And that makes sense from a social standpoint. We should. And the really famous image of this is there's this infamous face on Mars. There's a picture that was taken by one of the Viking orbiter in 1976 that made this picture from the surface of Mars, and people just immediately said, well, clearly there's an advanced civilization there that's built a huge face on the surface of Mars, and there's nothing else that this could possibly be. That is also a bit of an optical illusion. We see that, and it really does, boy, it really does look like a face. Here's an updated image of exactly the same place, and you see it's not really a face, okay? But if you squint at this long enough, you could make a face out of it. But this clearly isn't like some massive alien civilization building a face. If so, they're not very good doing it, right? And they just kind of got lucky in the shadow. So, this kind of thing comes up a lot when people talk about alien civilizations and extraterrestrials and stuff like that. Your brain kind of wants to see things, and you've got to be extra careful before you go around making claims that you've got evidence of extraterrestrial life, okay? So far, we've done an incredible amount of surveying of Mars. And since this early time where we didn't really know what was going on with Mars, today Mars is an incredibly well-mapped planet. I mean, you can go today, you can go online today, and basically you can get a global picture of Mars. It's incredible the precision to which we have mapped the surface of Mars. These are the landing sites for NASA missions to Mars. So each yellow dot are where we've landed different probes to the surface of Mars, and Spirit and Opportunity are two. So I showed you the Spirit rover there. One is there. Opportunity landed here. And there were a few other probes of the surface of Mars that have been landed over time. And the most recent one is the Curiosity rover, which has landed somewhere around here and is exploring something called the Gale crater on the surface of Mars. So I'm going to talk a little bit about that now. So this is the most recent thing we've got going on. Yeah?
So how do they decide where they want to land each of those rovers?
So they have different reasons for wanting to explore different parts of Mars. So they factor in a few different things. So at first, when they were first sending these probes to Mars, they didn't know precisely how well they could put it exactly where they wanted it. So they would tend to pick places that they thought were really safe. So they'd pick really flat regions that they thought, okay, we're not going to screw this up and drop this thing down into a crater. So it had to do more with safety than sort of geological exploration. But these days, there are very interesting features that we just wanted to explore. For example, this Gale crater is an interesting place that scientists think might provide hints of what early Mars was like because of the geological structure there. And so they'll pick it for those kind of reasons. So there's sort of different things that govern where we put them. And you notice they've kind of spread them all over the globe, and they're doing that on purpose because they want to get a sense of what different regions are like. So this is Curiosity. The thing is a big, it's a car. It's got these sort of four wheels, and it's driving along the surface of Mars. It's robotic. It's about the size of a compact car, so it's a pretty big thing, but it's not immensely big. The goal is to explore Mars's surface and determine whether or not it's potentially habitable now, which is unlikely, but more importantly, was it habitable in the past? Can they find evidence of past water, past evidence for life on Mars, and that kind of thing? They're looking for liquid water or past evidence of liquid water, essential elements, so sort of elements that are important for life, and perhaps whether or not there's a source of energy on Mars that then could be used for this life. This is actually a selfie taken by the rover itself, so it has a little selfie stick that it stuck out there and took some pictures of itself. This is actually 50 images all stitched together, and so you can see what's behind it, and you can see a little bit of itself there. So it's got all kinds of different kind of scientific instruments all over it. It's got a laser beam that it can shoot at rocks and sort of drill in. It's got some drill scoop here. It's got a weather thing that's called REMS that's reading the weather all the time. It's got all kinds of different imaging things. It does some chemistry with this little different experiment. So it's got all these little different experiments kind of strapped all over it. And they go around and scoop up some dirt and do some experiments with it. And so this is the first of its kind in that kind of rover where not only can it go and take pictures, but it can actually do little sort of chemistry experiments with the stuff that it picks up. This is something you can go and get online right now. You can go to marsweather.com. So this little thing, the REMS weather thing, now is constantly sending information back to the Earth, or every now and then it's sending information back to the Earth. And you can see what it's experiencing for its weather over the course of the day. And so this was the report for today that I grabbed a little while ago. The range of air temperatures on the surface of Mars where it is today, it goes from a minus 100 degrees, so very cold, but up to something just a hair above freezing. So it's not, there are times where it's actually warmer in certain places on Mars than it is in certain places on the Earth. So it's not that extreme differences, but usually it's a lot colder on Mars than it is on Earth. The pressure is very low. What they do is they quote things in sols. So sols is a Martian day, so 24 hours and 40 minutes. So they quote things in terms of sols. So this is sol 737. They even do an equivalent month. So it's the equivalent of a Martian October there right now. Okay, it's swinging into fall, fall season where the rover is right now. And so they know when the sun's going to rise and when the sun's going to set, all that kind of stuff. So they do all that kind of stuff. And it's just kind of fun that we know that well what the conditions are on the surface of this planet. That 100 years ago we thought there were canals. We didn't know what the heck was going on in the planet. Now we know so much about it. It's really pretty amazing. The target of this mission was to slide into this particular crater on the surface of Mars that people wanted to explore because maybe it was exposed sometime in the past. We can figure out what was going on the surface of Mars and learn about what was going on in the past on the surface of Mars. Now, so the reason why they never have tried to do this before is because I was talking about this before. So these are sort of the error ellipses, so how well they could actually place a lander where they were trying to place it on the surface of Mars. And this is the crater they're trying to get to, okay, right here. And you can see that even, if you talk about sort of the Pathfinder probe, they could have never put the thing very close to the crater without not knowing for sure that they were going to just drop the thing right in the middle of the crater and destroy it. And so only very recently with this lander have they been confident enough with the precision to be able to place this thing. Basically, they placed it right at the edge of the crater, which is where they wanted to put it. And then they're going to roll into the crater and sort of explore it later on. So we're getting better at putting things where we want to put them. It's actually kind of freaking amazing what they were able to do. So this is a movie that's going to walk you through exactly what was done. So not only did they get this thing to the planet Mars, which is, if you think about it, actually pretty amazing that we launched something from Earth and got it to the planet Mars. And then this is what happened. This is how the rover was delivered to the surface of Mars. So of course it's coming in, there's some atmospheric braking because there is a little bit of an atmosphere on Mars, but it's not that much, so it doesn't slow down that much, and so it has to have other ways of slowing it down. So the first thing that happened is they throw out a parachute, which is sort of the kind of thing you've probably seen before, and it slows it down some. But then that's the rover they're going to drop out of the thing. So there were little jetpacks on it that kept it from falling straight down, and they ended up very slowly getting this thing to the ground. Now this is just a movie that they made to explain. Oh yeah, this is the craziest end part too. So now it hovers and they just lower the actual rover down on this line. But they actually did a live movie of when they did it, and it was it's sort of crazy to watch it live. It's not as pretty as this one, but so I showed you this one just so you could see what's going on. This is just an artist's depiction of what happened. So then they launched that thing off to wherever to sort of get it out of the way so it doesn't destroy the rover. So then that thing just goes and lands off somewhere. And so that's it. So it's got these 6 wheels on it, and it's built in a way that it can kind of roll around like this. Okay, so this is just sort of giving you a sense of what it would look like. Now, this is actually a picture that was taken, this is a real picture now taken from above when the thing landed. It turned out that when the thing landed, it kicked up all kinds of rocks and dirt and stuff like that up to the top of the rover. And you can see it kind of lying on the top here, that it kicked all this stuff up to the top. And they were concerned that it was actually going to destroy some instruments. They didn't realize that the surface of Mars was going to be that easily kicked up. So rocks and stuff kind of hit some of the instruments, and they were very nervous about that. But at the end of the day, things worked out all right. This is another picture from the surface of Mars. Pretty soon after it landed. Interestingly, when it came down like that, remember how it kicked up dust and it landed on the top? That actually uncovered some rocks that had been covered up in dust. So then they were able to take pictures of these rocks. And interestingly, the first thing they saw right when they landed on the surface of Mars, they had taken the dust off these rocks by the rockets and stuff. And they showed that these were exactly the kind of pebbles. The pebbles showed rounding in structure on them, which is exactly what you would expect for pebbles that had existed at the bottom of a stream or a river. That is, it looked like exactly like the kind of structures that you see deposited on a water flow. So the first thing they did when they landed is they looked like they were sort of in the sort of bottom of an ancient riverbed that might have had flowing water on it in the past. If so, right, this is very, very important because it means that probably in the past there was flowing water on Mars, probably had a thicker atmosphere, probably was a bit warmer than it is now, and under those conditions you would ask yourself, well, maybe life got a foothold a couple billion years ago on Mars and just didn't evolve to the point that it has on Earth because conditions change so much over time. It's kind of interesting to think about what these people do when they're studying Mars. So they want to use all the time they possibly can. Now the rover is awake during the day. It roams around during the day, and that's because it gets some of its power from solar panels. So it wants to do things when the sun is out. And now the way you run the rover then is you actually operate on Martian time. So you have a team of researchers working out at JPL, and they're working on Martian time, so they don't want to waste any time here. And so what they do is at 10 a.m. Martian time, okay, pretty soon after that, the rover wakes up. They've programmed it the night before to do what they want it to do, and it goes off and starts going around and digs holes and does whatever it does for the course of the day. And then they put the rover to sleep to recharge its batteries and not waste energy when it doesn't have access to the solar panels. Now, as soon as the rover goes to sleep, then the people start working. Okay, so they have 2 shifts of people that basically work continuously while the rover is asleep to sort of figure out, digest what the rover found during the previous day and to tell it what to do the next day. And then as the sun comes up on Mars, the rover starts going again. And so every day they do this. And especially when it first started, they were just working kind of nonstop to sort of... Now the thing to keep in mind is the Earth day is 40 minutes off of this. So while they might have started this in some reasonable way, over time your shift shifts 40 minutes every day. So imagine coming into work, but you come into work 40 minutes later every day. Now the first few days it might not be that weird, but after a while you're now working in the middle of the night, and then you start working in the morning again. And so the people working on this lander had these really weird hour shifts where they would start working in the afternoon, and then they would have time off, and then they'd start working in the early morning. Yeah?
Is there like a lag between the time that we send a command to the rover and
Yeah. Yeah, right. So it's the delay, it's sort of the light delay time to get to Mars. And so you're talking about sort of tens of minutes typically to when you send it to when it gets the signal. But then, then you'll sort of process what happens. But it's basically like you program it and it does it. And then the next day you see what it did and see what happened. So if a Martian jumps out in front of it, you can't react to that. Like, so we're not expecting that to happen. But if some crazy thing happened, like something crazy unexpected happened, you're not reacting in real time at all. It's just you dial up what it's going to do, for the whole next day. Then you let it do that, and then you plan for the next day. Yeah. Right. So. So you see that while if you keep this schedule fixed on Mars, which is what they do, this is what Earth time was doing on August 6th, and this is what Earth time was doing on August 11th. And it just shifts everything off like that. Okay. One of the things that it wanted to do was go to the base of this mountain called Mount Sharp. That was 5 kilometers away, and it takes the rover quite a long time to travel 5 kilometers. This is just an image where the rover had driven across the surface of Mars, and you can see its tracks. This is its tire tracks that it left on the surface of Mars, and it just turned around and took a snapshot of it. Overall, so far what the rover has found is that, at least in ancient times, we're talking billions of years ago, Mars definitely had an environment that we would call habitable. Okay? It looks like there's river or stream deposition environments, so there was almost certainly liquid water flowing on the surface of Mars in the past. If you study the mineral deposits in the sort of these flows, it looks like the water was non-acidic, and so that's good. It wasn't highly acidic water. It looks like these sort of the CHON elements were there. The carbon, hydrogen, nitrogen, oxygen, sulfur, and phosphorus were all present. These are the important elements for life, at least here on Earth. So at least those elements were there, and there were at least extended periods of time where you had water existing on the surface of Mars in the past. So that's interesting. I mean, it's not as cool as it would be if there were rainforests covering the surface of Mars today, but it does suggest that at a time in the past there was liquid water on Mars, and it makes people very interested in looking for clues of maybe ancient life on Mars, or perhaps even microbial life today under the ground. A few other things about Mars, since we're talking about Mars. So Mars is sort of our best example of an alien world. And we can sort of look at it to see, well, what kinds of things might change as you step onto an alien world, and what kind of things might be the same and might be different. So one of the things that's very interesting about Mars is it has the solar system's largest volcano. So it looked like there was volcanism on the surface of Mars up to about 150 million years ago or so. This is called Olympus Mons. It's actually located over a hot spot. Now, if you recall, I talked about how the Hawaiian Islands were formed because there's a hot spot out in the Pacific Ocean that's spitting up lava. And where that lava has come up, it's created the big island of Hawaii is the thing that's basically just finished being built right now. And the first island was, Kauai was built a long time ago. And so it's sort of this, you've got a plate that's running over this hot spot that's spurting up, but eventually the plate shifts over, and that's how you get island chains. This volcano on the surface of Mars does not have tectonic activity. So there's a hot spot that it was positioned on top of, and it never moved away from that hot spot, and it just kept building up in that same spot. And that's how it got to be such a very large volcano. This is the size of the volcano in comparison to the state of California. So you can see it's huge. It's basically almost as large. It's basically as large as a large state. So it's incredibly big. It's much, much larger than any mountain or volcano on the surface of the Earth. Here's a comparison, for example, of Olympus Mons on the top compared to Mount Everest here. And this is Mauna Kea, on the big island of Hawaii here. It is just immensely big. And again, where on Earth you get island chains, for example, you have a hot spot, but you have the plate moving by it, so you tend to get chains like this. On Mars, there's no plate tectonic, so it just keeps piling up in one spot. The other thing that's important about the surface of Mars is the gravity is weaker. And so where on the Earth, if you build a mountain too tall, eventually it'll become unstable just because of gravity, and it'll just sort of topple over. Mars, the gravity is weaker, and so you can have much taller mountains. And so anyway, this is just an incredible feature on the surface of Mars, and I'm sure there's people who study Mars who would love to go sort of explore and send robotic probes looking at Olympus Mons as a potential site of exploration. The other thing that Mars has is gigantic rift valleys. Okay, so on Earth we occasionally have these rift valleys where you have the surface of the Earth sort of coming apart. But this is the biggest rift valley in the solar system. It's shown right here, right across. And you can get a sense, this is the edge of the planet. Okay, so you can see that this single rift valley is covering almost an entire hemisphere of the planet itself. So it is just an immense thing. It's, again, the largest valley like this in the solar system. This just shows you, here's the valley again. If you were to put a map of the United States on top of this rift valley, it's basically the size of the continental United States. So it's just a gigantic thing. Oh, and by the way, here's a few volcanoes here, just to give you a sense of scale. So these are giant, right? I mean, this is much, much larger than any kind of mountain or single volcano you would ever see on Earth. What's shown here is kind of a topographical map of Mars. And what you see is that in the north, basically the whole northern half of Mars is lowlands. That is, it has lower sort of altitude than the south. And it's also very smooth, where the south is older and cratered and sort of pockmarked. Up here, sort of the northern half of Mars is this kind of smooth thing. And if you look at this long enough, it almost looks like an ocean basin. And in fact, people think, oh, here's that big volcano. That's Olympus Mons. And there's the big Rift Valley, just to sort of give you a sense of scale here. And you see the Rift Valley, by the way. Blue means low, means deep. Okay, so it's very deep there, and then you've got this sort of deep stuff right along the top. And then there's another big crater right there. If you study the surface of Mars, you can see just from sort of satellite imaging that it looks to have what look to be outflow channels. So what look like sort of what would happen if you had a catastrophic flood on the Earth. It washes stuff away and creates these kind of outflow channels. And so there's other evidence as you just survey the surface of Mars that at one point in the past there was this liquid water, and the liquid water was flowing in this kind of interesting way. It looks like the water was flowing that way. Look at this right here, okay? See that those wiggles? Like you see this line and then all these little wiggles? That looks like a river delta. Okay, if you've ever looked at like the Mississippi River Delta from space or on maps, this is exactly what it looks like. Okay, so you have these sort of geographical features that really look like at some point in the past there was flowing liquid water on the surface of this planet. Interestingly, you have flows that don't have very strong impact craters. You don't have a lot of impact craters that have covered up these sort of flows. Now, keep in mind that there's been a rate of stuff raining in on planets in the inner solar system for the last couple billion years. Okay, every now and then something hits the Earth, right? And we have craters like that on Earth, going back sort of that we can find easily, going back sort of 50,000 to 100,000 years. But it gets harder and harder to see these craters after a while, right? Because the Earth turns over and you can't see those ancient craters. The fact that you see these riverbeds, okay, or these flow patterns that are not covered up by meteor strikes suggests that they were at least not that long ago, that they haven't been obliterated by just having stuff impacting the surface of the planet. So that allows you to give some rough age estimate that it wasn't, 4 billion years ago that these things were happening. It could have been, reasonably recent, in geological timescales, perhaps reasonably recent time periods. And in fact, there are some narrow gullies that might be less than a few million years old, which is kind of astounding if you think about it. It's not clear how exactly you would get flowing water, but it could just be that you had some ice deposit, you had a catastrophic impact or something, or some geological impact that heated up the ice enough that allowed it to flow as water for a little while before it then sublimated. So it's not clear exactly how you get flowing water in those conditions, but it does look like that there was some happening. The other thing that we're quite sure about is that there's all kinds of water locked beneath the surface of Mars right now. So this is actually a map of water beneath the Martian surface. Really, it's water ice, so it's frozen in water ice that we think is sort of locked into the surface of Mars. And in fact, the purple and blue is where we have a lot of ice. So you can see here on the polar ice caps, there's a lot of ice there. That makes sense. We've talked about that before. But even out here in the middle of the planet, underneath the surface, there looks to be frozen water ice locked in there. What you're actually seeing here, by the way, is the experiment is mapping out where hydrogen is, but we interpret that hydrogen as H2O. So when Curiosity actually dips its claw down into the water, down into the soil of Mars, and it can figure out that actually about 1% to 2% of it is in fact water by weight. This water is locked into minerals, but again, it suggests that there was a time where water was pretty abundant on the surface of this planet. So the conclusion based on all this stuff, I've shown you a few different pieces of evidence, is that Mars in the past was a warmer and wetter place. So this is an artist's conception, but you could imagine a couple of billion years ago, if you took a picture of Mars, it may have looked like this. Okay? And in fact, it may have been that there was this northern ocean, which is why we have these lowlands in the northern part of Mars. But then as time progressed and maybe the atmosphere got thinner and conditions got colder and less conducive for liquid water, it turned into something that looks like the planet today. Now, if so, this is interesting from sort of an origin of life point of view, okay? Life in the universe point of view. Because, if you just imagine yourself back 3.8 billion years ago, the conditions on early Mars may have been very similar to the conditions on early Earth. They both had substantial oceans, okay? Therefore liquid water, perhaps. Probably it was true that there may have been more geological activity on the early Mars because the thing's younger and hasn't cooled off yet, okay? And we know that about 3.8 billion years ago is basically when life, we think, first got a foothold on Earth. So if the conditions were similar on Mars, if we were to find evidence that life also got a foothold on Mars, that would mean something pretty profound, right? That would suggest that whatever conditions led to the origin of early life on Earth are pretty, it's a pretty common occurrence. So you give life the right conditions, it happens. And then what happened on Mars is, because of global geological features and the positioning of it relative to the sun and other things, the planet eventually dried out and got cold. And that killed off at least any complex life that would have been thriving on the surface of Mars, whereas we got luckier on our planet. But what that suggests is that if we go out and start finding planets that are like an early Earth, like Mars is around other stars, the chances of finding life on those would go way up. Are there any questions about this? Okay. Okay, so this is what I would say about the summary. So what do we know about about life, the possibility of life in the climate on Mars? Okay, we know today that Mars is cold. It's dry. It's got a very weak atmosphere, and therefore it's unable to have a stable, conditions for liquid water. So there are no seas, there are no lakes. None of that kind of stuff exists on the surface of Mars today. And so for that reason, we don't think that there's anything like the grand variety of life like we have today on Earth. However, there is abundant water ice under the surface of Mars. And so maybe under the surface of Mars, there might be some form of life that might be able to sort of exist in those conditions. There's a lot of evidence for ancient oceans and flowing water on the surface of Mars. And even more recent, short-lived flows of water on the surface of Mars. If so, that really suggests that there were conditions, at least at some point in the past, maybe a couple billion years ago, where life, perhaps not that much different than what life was like on Earth 2 billion years ago, could have existed. And this is the thing that gets people excited, and it's one of the reasons why we keep sending probes back to Mars to kind of hunt for signs of this kind of thing, if it's there. And it's one of the things, of course, that if we ever sent humans to Mars, you'd have sort of real geologists there trying to do these experiments more carefully than you can with a rover. So, big picture is there complex life on Mars today? Probably not. Was there life at some point in the deep past on Mars? Very possibly. And if we find evidence for that, it has really profound implications for our expectations for life, maybe in other places in the solar system, but certainly throughout the galaxy. If we were to find no evidence for past life on Earth, even in the past when we thought conditions were very similar to those on ancient Earth, that would also have profound implications, right? Because it would suggest that something special happened on Earth, and maybe life is a much more rare thing than we might have otherwise thought. Okay, that's it. We'll see you Thursday.